Okay, Coroneos are 100 integrals, numbers 27. All right, so this is the question. We need to integrate dx over 1 plus x squared and square it. All right, so the way to do this question here is, again, very similar to the previous question. If you pay attention to 1 plus x squared, that really looks like, that's a trig substitution that you need. So we're going to use the Pythagorean identity 1 plus tangent squared theta is equal to secant squared theta to do this question, and hopefully we can solve it quite easily. All right, so we'll start with the question by letting x equals to tangent theta. So therefore dx is equal to sec squared theta d theta. All right, so now I'm pretty sure we can now substitute everything we have. So we've got dx, which is the sec squared theta d theta. All right, so let's just put everything inside and let's see what happens. All right, so the numerator will get sec squared theta d theta over. The denominator is 1 plus tangent squared theta, and we're going to square it again. All right, so the next line of working out, we'll end up with sec squared theta over. Now, 1 plus tangent squared theta is equal to sec squared theta, but we have to square it again, d theta. All right, so now if you just pay attention to the numerators, we've got sec squared theta. We can cancel the sec squared theta with the denominator square there. All right, so we end up with 1 over sec squared theta d theta, which we know 1 over, sec squared is equal to cosine. So therefore, that's integrating cosine squared theta d theta. All right, so to integrate cosine squared theta, we need to use the double angle formula for the cosine 2 theta. That gives us half bracket 1 plus cosine 2 theta d theta. If we take the half outside, we end up with this. So now we should be able to integrate this one pretty easily. All right, so we need to have half. To integrate 1 is equal to theta. Now to integrate that cosine 2 theta here, we need to use something called a reverse channel. So the derivative of 2 theta is equal to 2. So we need to have a 2 here, which means we need to have half outside to balance it. All right, so that gives you the reverse channel. So that gives you half sine 2 theta here. So we know that is equal to half sine 2 theta. So we can change that into half sine 2 theta and plus c. All right, so please remember we haven't finished the question. What we need to do is to replace the theta by x. Now we know from the previous substitution, we know x is equal to tangent theta. So we can create a right angle triangle and we can find out the ratios we need. And that's x here, that's 1. So the hypotenuse will be equal to 1 plus x squared. All right, so let's start with this. So that's theta, we're still going to change into theta here. Now, this one, that's sine 2 theta, we can use the double angle formula. So that gives us half times by 2 sine theta times by cosine theta plus c here. So you end up with half theta plus sine theta multiplied by cosine theta. The half and the 2 cancels out. So therefore, now we can replace everything in. So we know the theta is tangent inverse x. All right, the next one is, what is sine theta here? Now sine theta, based on this triangle here, sine theta is equal to opposite over hypotenuse, which is that one there. Okay, so that's what sine theta is equal to. Now what does cosine theta equals to? All right, so the second term is the cosine theta, right? Cosine theta, which is that one there, cosine theta, again, according to the triangle, it is adjacent, which is 1 over the hypotenuse. So 1 over 1 plus x squared. And that's what cosine theta is equal to. All right, so now we can substitute everything back inside. So we've got x, that's a plus here. Okay, so plus x over square root of 1 plus x squared multiplied by 1 over square root of 1 plus x squared and plus c. All right, so therefore after we multiply these two together, we should be able to get a half tangent inverse x plus x over 1 plus x squared, okay, and plus c at the end. Okay, you can multiply the half inside, but I don't think it's necessary. Okay, so that's the way to do this question. Again, interesting question. You need to realize this is a trig substitution to do this question by looking at, 1 plus x squared. That 1 plus x squared really, similar to the Pythagorean identity. And you need to go through the steps. Don't forget that you also need to replace the theta here, all right, by the x at the end. All right, thanks for watching.